Okay, so let's talk about Unit 3, Lesson 2, Example 10. This is Unit 3, Lesson 2, Example 10. And I will a little bit of, when we start doing applications of integration, we are going to have to understand how to graph x as functions of y, which is something we do not do enough of in our pre-calculus and algebra 2s. When we think of is something a function, we always think of, is it a function of x? That, ladies and gentlemen, is a function of y. That gives x as a function of y. If I were rotate my human self and would go like this, oh, it does pass the horizontal line test. And if graph passes a horizontal line test, it is a function of y. X is a function of y. So let's know that. But what I want to do, but I am in, thanks to Renee, I am still in XY land. In XY land, it is important to note that the horizontal axis is x and the vertical axis is y, and that they are perpendicular thanks to Rene Descartes' friends. And since I am in XY land, when I talk about the equation of a tangent line, I am always talking about what creature? If I'm talking about the equation of a tangent line, the slope of the equation of a tangent line is given by, the slope of the tangent line is given by dy dx. Thank you very much. So I want to find and graph the equation of the tangent line to x equals y squared. Doesn't matter if I'm looking at a function of x, a function of y, a parametrically defined curve, a polar defined curve, all things that we're going to talk about down the road. The slope of the tangent line is always dy dx, always, because the y is vertical and the x is horizontal, and the slope of a line in xy land is defined as change in y over change in x. So I'm going to find dy dx, which is the slope of the tangent line. So pretty straightforward. I'm going to take my equation that I have, and I'm going to dx this thing. And I'm going to differentiate the left side, and the derivative of x with respect to x is 1. And then I'm going to differentiate this guy right here. But before I differentiate that, I'm going to write it this way. That's y to the negative 2. What is the derivative of y to the negative 2? This is going to be negative 2y, negative 2, y to the negative 3. But I have to do what? What's the inside of that? Y. What's the derivative of the inside? dy dx. So derivative of the outside times the derivative of the inside. I'm going to clean that up a little bit. I'm going to write it this way. And I'm going to really clean it up because I want to solve for dy dx. And if I solve for dy dx, I'm going to multiply by y cubed over 2. And this is going to be true or false. You good, Ryan? Good, Nick? Down there, I can never see you, big dog. Okay? So that's the derivative. I want the equation of the tangent line at 1, negative 1. The equation of the tangent line never changes. Oh, what is dy dx at this point? What is dy dx at the point 1, negative 1? That's going to be negative 1 cubed is what? Negative 1. Negative negative is positive. That is going to be 1/2. So this is going to be 1/2 x minus 1. And oh, it's a daggone good thing that that slope came out positive, because look, if I graph the tangent line as I'm going to, what color you want to use? Do blue. Because I want the tangent line to that point right there. Tell me, yay or nay, does that have a positive slope? Yes. And you know what? Actually, my tangent line isn't just right, because it should be going through, it should have a 0 right there, because it should be up 1 and over 2. So I'm actually going to see if I can't fix my tangent line a little bit. And I'm going to try to do this. That's a nice tangent line, big dog, because that tangent line goes up 1 over 2. Alrighty? So I have the equation of the tangent line. I have dy dx. I evaluated dy dx at the point 1, negative 1. I plotted the tangent line at 1, negative 1, and that was the solution to the problem. Here we go. Example 11. Let's get videoing. Okay, so for example 11, what they want is the second derivative of this equation. To find the second derivative of this equation, the first thing I have to do is find the first derivative. So let's dx the crap out of everything. And the derivative is 16 is 0. Happy daggone New Year. The derivative here is going to be 2x minus 2y dy dx. And it's amazing how many times that we differentiated y squared just in these notes with respect to x is equal to 0. So I'm going to now solve for dy dx. Ah! Sorry, I didn't mean to alarm you, Katie. You get a little bit alarmed when I scream and holler. Subtracting negative 2x. Now I'm going to divide by 2y, and it looks like I have dy dx is equal to x over y. False. Now, I was verified that I did do a correct job on finding dy dx. Now I have to dx the daggone thing again, because I want to find the second derivative. So I have to dx the whole daggone thing. The derivative of the left side, by notation, is simply the second derivative of y. This is what I want. But, ooh, how do I do this? I have to recognize that this is a quotient. Therefore, I have to use the product rule. Correct? Heavens no, I'm going to have to use the quotient rule, Jace. So what I'm going to do is I'm going to come over here, and I'm going to let f equal x. I'm going to let g equal y, and f prime is 1, and g prime is dy dx. Hello. Yeah. And look very carefully what I'm going to do, and this happens a lot. Hey, what is dy dx? X over y. So I'm going to put x over y in for this, because that's what dy dx is, x over y. That's going to make everything come out real nice. And so now I'm going to employ the product, the quotient rule. Pardon me, I don't mean to be that way. It's going to be f prime g minus g prime f over bottom squared. F prime g, y. Yeah. F prime g is y minus, what is x times x over y? X squared over y, true or false? True or false? I never want to leave, keep in mind, this is that second derivative that I wanted. I never ever want to leave a complex rational, and you learned in pre-calculus the way to simplify complex rationals was to multiply the top and bottom by the least common multiple of the separate denominators. There's only one little denominator, and that little denominator is y. So I'm going to multiply top and bottom by y. And look what I have. I have y times y is y squared. Y times x squared over y is x squared over y cubed. And that is the second derivative. That is the desired goal. Oh! 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 So here we go. We're going to consider the inverse trig function. Y is equal to inverse sine of x. And we're going to find dy dx. So let's do some trigonometry first. If I have this statement right here, true or false? Gonna be true. Because if I sine both sides, sine of inverse sine is x by the definition of inverse functions. And what I did was I just signed both sides. Should I write that step out? Are you okay with that statement right here? Are we okay with that? So what I'm going to do, and the same thing I did in pre-calculus, I'm going to take this statement right here, and I'm going to create a right triangle. This y is what kind of a creature? And I know that anyway, because arc sine pops out an angle. So this guy right here is y. That angle is y. And by the geometric definitions of the trigonometric ratios, the sine is what? Adjacent over hypotenuse or opposite over hypotenuse? Opposite over hypotenuse. So that, another way I can write x is x over 1. So this guy right here is going to be x. That length is going to be x. That length is going to be 1. And guess what I'm going to do? I'm going to use some basic geometry, and I'm going to solve for that side length. You'll find out why I want to solve for that side length in a minute. And I'm simply going to let that side length be b. And now I know, true or false, b squared plus x squared is equal to 1 squared. And I'm going to solve for b, and b squared is equal to 1 minus x squared. And since we're talking about lengths of triangles, b is going to be the square root of 1 minus x squared. You'll understand in a moment why I came up with that. Geometry and trigonometry. Trig and geometry. back to calculus. Now I'm going to d dx both sides because my goal was to find dy dx. So I'm going to d dx both sides of this. What's the derivative of sine? Cosine, correct? So this is going to be cosine of y. What's the derivative of the inside? Dy dx. What's the derivative of x? 1. So what is dy dx? Dy dx is equal to 1 over cosine of y. Hello, neighbor. What is cosine of y? So this is going to be 1 over the square root of 1 minus x squared. And that's what dy dx is. If I have an inverse trig function, the derivative comes out to be algebraic. Okay, so let's find this rascal. And I'm going to actually follow the steps that I did in the previous example. If y is the inverse tangent of x, it certainly follows by the definition of inverse functions that the tangent of y is equal to x. I'm going to use this, and you will find out in a bit why, to sketch a right triangle. I will sketch the right triangle. And this guy right here is going to be y. And I know that the tangent is opposite over adjacent, so this x is simply x over 1. So this is x, this is 1. Keep in mind this is a right triangle right there, right angle. And now I'm going to find, we can call it whatever we want. I'm just going to follow the convention given in geometry and let the hypotenuse be c. And now I know by the Pythagorean theorem that 1 squared plus x squared is equal to c squared. And since we're talking about lengths of triangles, c is equal to the square root of 1 plus x squared. I will use that. Now I'm going to d dx both sides over here. D dx here. And I'm going to need to remember, what's the derivative of tangent? Secant squared. So this is going to be secant squared of y times the derivative of the inside, which is dy dx, is equal to 1. Now I'm going to divide both. But hey, keep in mind, hello neighbor, what is secant squared? 1 over cosine, correct? So before I do this, I'm going to write this way, because it's easier for me as a math teacher to explain what's going to happen the next step, because all I'm going to do is I'm going to multiply both sides by cosine squared. And now I have dy dx is equal to cosine squared of y. Hello, neighbor. If you look at your right triangle, what is the cosine of y? Well, the cosine of y is equal to adjacent over hypotenuse, so that's going to be 1 over the square root of 1 plus x squared. True or false? And now tell me, what's cosine squared? Cosine squared over here, home schoolers, is this thing squared, which is 1 over 1 plus x squared. So what is dy dx? This would be a hard lesson to miss, would it not?